Alright folks, today we're going to be talking about translating a set of data. That means we're going to take a look at some patterns that happen when we add or subtract the same number to every single element in a set we're given. So, we're given a set here. It's the 11 workers and their daily earnings in dollars, and our job is to see what happens when there's a $275 tip that's divided equally among the workers. Okay, so it tells us find the total amount including tip received by each employee for that day. Okay, so first employee made 60, but we want to add in that tip. So our first job here is to, of course, decide how much each person gets if we divide that up evenly. So we'll start out with dividing that 275 divided by 11, and that tells us we're going to give each person $25 tip. All right. Now, once we have that, okay, we can just individually add these $25 to each piece. Okay, but we know our calculator will kind of help us speed up some of this process. Now with $25, it's pretty easy to add these, but what we're going to do, or what I'm going to have you do, is go ahead and put this data in list 1, because we're going to look at certain statistical measures on the original set and the translated set, so let's get those in automatically. So what I want you to do is pause the video and type in that list into list 1, and then we'll talk about what to do next. Okay, from here I said you can speed up this process just a little bit. Okay, if you want to add 25 to all of these, you go up to list 2 and just say take list 1, second one, and then plus 25, and that'll go ahead and add them for you. Okay, so we should have now in list 1 our original set and list 2 our translated set. Okay, so make sure those numbers get jotted down for number 1, and then we can move on to filling in our table that you see next. We're going to look at the mean, median, and mode, and then range, IQR, standard deviation, and variance. Okay, remember our mean and median, sometimes they call it mode, but not really, are our measures of center. And then our range, IQR, standard deviation, variance are our measures of spread. So what we're going to do is see what happens when we translate the whole set to each of these different types of measures. So hopefully you remember when we're trying to calculate the mean and all that good stuff, we want to go to the Calculate menu under Stat. So we hit Stat, Calculate, and then One Variable Statistics. We're looking at list 1 first here, and then we can go ahead and plop some of these values in our table. So our mean here is 70. Median is with the quartile 1, quartile 3, that stuff, so median is also 70. Mode, we'll just have to look at our original set, because mode means the most frequent. It's not something that pops up in your table. So if we go back here, the number that shows up most is 72. Range is just your max minus min. So while it doesn't show up directly, those two values are in your calculator. Minimum is 60 and the maximum is 80, so that gives you a difference of 20. IQR, we take our quartile 3 minus our quartile 1. So quartile 3 is 72, and then quartile 1 is 67, so that's a difference of 5 there. Standard deviation, we're going to always use our sample standard deviation versus our population unless we're instructed otherwise. Okay, so that's 5 as well. And variance, you just square that to be 25. Our label on all of this, okay, it matters. We have to make sure that we get dollars. And then remember, since our variance was $5 times $5, this is really $25 squared. Okay, notice how you went ahead and wrote it out because we can't really write dollars squared. Dollars going on the front side squared would mean the number gets squared, so it'd look kind of funny. Right, so now what we want to do is the same thing for the translated data, but that's in list 2. So you still go stat to calc, but then in your one variable statistics, you're going to hit second and then 2 to change it to list 2. Okay, what I want you to do is go ahead and pause the video and get that list filled out for me. What we're supposed to do here is describe the effect of the tip on what actually happened. Okay, so from the mean to from the first set to the second one, you'll notice the difference here is exactly that $25 tip. And that happened for the second one as well. Mode also increased by 25, but each of these last 4 stayed exactly the same. So our measures of center all increased by that $25. And that was our mean, median, and mode, which again, mode's not technically a measure of center, but it is a individual item in the set, and so that kind of gives you an indication that it will be affected that way as well. Then our measures of spread all stayed the same. And the book likes to use the word invariant here. So just so if you see that word, you know what it means. It means it just didn't change at all. And these are our range, IQR, our standard deviation, and our variance. Now, remember I said the mode acted this way because it was an individual item in the set, whereas the range, IQR, standard deviation, and variance, all of those are measures of spread, which means they're calculated using a distance measure. You take this minus this. Let's just focus on range to kind of talk about this. When I look at a number line, and my range here was from 60 to 80, for the original set, and I take both of these numbers and shift them up 25, the distance between them doesn't change. So that's kind of the idea here. With those measures of spread, we're talking distance, and since we're adding that same number every single time, the shift is actually constant there on both, which means our distance doesn't actually change. Last thing we're going to do is kind of see if that same effect happens if, instead of adding the same number to the set, we end up subtracting. So number 4, it says, suppose that instead of a tip being added, $5 was deducted from each worker earning for a staff holiday party. Find all the measures in column 1 of the chart above for the new data and write them beside the third column. So let's go back to our calculator. In our list, what we can do is just clear out this list too and basically repeat that process. Now $5 is deducted from each one, so we can hit second list 1 and then subtract that 5. All right, so our new numbers here, 55, 61, 62. Our job is to fill in the column that you saw the minus 5, basically. So We will stat, calculate. We should already be set up for list 2 in our one variable statistics, so we shouldn't have to change that. But now we're going to use this to fill in this third column here, those numbers. So what I want you to do is pause the video and take care of that last column for me. Okay, hopefully you saw that the same pattern ended up happening. So I don't want to repeat myself too much here, so I'll really shorthand. Okay, we're looking at this compared to the original, but the measures of center all were $5 less. And then the measures of spread were invariant. So it does not matter whether our transformation is a translation that's positive or a translation that's negative. The distance doesn't change, so measures of spread won't change, but the individual items in the list will, which means all of those measures of center and items like just quartile 1 or just the median, those will all stay exactly what the transformation says it was going to do. Last thing we're going to do is just kind of generalize this on a note card. So what I want you to do is pause the video and copy down kind of this idea on a note card. It says, when you're translating a set of data, if H is added to each element of the set, so I'm just using H since we're talking about only one variable here. We're just dealing with one list at a time, and we always use H to talk about a translation with X. So measures of center, you take the mean that you had and add H, the median, the mode, all of those just get a plus H, and then the measure of spread all stay the same. Okay, so copy down this on a note card and you'll get to use that for the remainder of this chapter. If you have any questions on the concepts that we talked about today, please feel free to come see me.